Hello everyone, hope you are doing well. I am Akshay Parmar, Assistant Professor at LJ Institute of Engineering and Technology in IT ICT department. Today we will discuss signals. What is signals, what are its type and what are the form, that all the things we will discuss today, right? What do you mean by the term signals and where does it is used in our day-to-day daily life? Is there any idea? Whenever we heard any audio, that audio can be recorded with the help of the microphone, right? After recording that audio, we can transmit the data from one destination to another destination. So, well, let's start with what is signals, right? Signal is basically a function, right? So, in the simple language, signal is a function. That function varies depending upon the individual variable. In other terms, the signal is a function that represents the variation of the physical quantity with respect to any kind of parameters, right? That parameter is called the individual variable. Let's take an example, and for an example, person X, or you are given a task to measure a atmospheric temperature between a particular time duration and record it, right? For an example, person is given a task to measure atmospheric temperature between the 3 p.m. to 9 p.m., right, and record it. Suppose that the person is having such kind of device by which he is able to measure and record the temperature at each and every second, right? So after the recording all the data, what will he do? He will plot the data into the graph, right? After that, the person now plots the data, recorded data into the graph, right? Here you can see that there is a timeline, and after that the temperature chart is there. Here you can notice that the temperature is decreased with the interval of time is passing, right? The temperature is decreasing with respect to time. So here the person has measured the value of temperature at each seconds and plotted into the graph. And here we can found that the temperature is decreasing with respect to time. So we have found that the function temperature is inversely proportional to the time, right? This is how the signals are work. In the electronics, the signals are varies with the physical quantity with respect to time. The signal variation of the electric quantity is with respect to time. In the most of the cases, the signals are the electronic quantities are voltage or the current. If the electrical quantity is remained same for the different time, so we will get in one single line. If the electrical quantity remain the same for the different time, so we will get an ideal line for each and every time, right? For an example, with increasing the time, the current or voltage is not changing, then it is not a signal. It is simply a direct current value. We can say that a DC value. There are mainly two kind of signals there, analog and digital. Let's see the analog signal first, right? The signals that can be taken value within the given limit. Any kind of voice is the form of the analog signal. Here we can take any value between the given time limit. Here in the graph you can see that you can take any value between the 0 voltage to the 5 voltage. You can take the any of the you can take the any of the value between the 5 voltage and the 0 voltage at the any given time interval, right? So the value is defined as each and every second and it is continuously. We can measure or locate the value of the quantity at all the specific time. As you can see that you can measure or locate the value at any of the time interval or any of the specific time, right? What if you are measuring that in a particular certain time interval, right? So it is called the discrete time signal. It is a signal which is defined for discrete interval of time. Taking the previous example only, here we discretize the time in the equal time interval and we can have the value defined at the each of the particular time interval. As you can see that at the time t1 you can get the point at this point, right? After that, at the time interval t2 you can get the measurement at this point. After that you can get the measured value at the time interval t2 at this particular point. So this is how the discrete time signals are measured, right? This is how we can get the discrete time signals there. Here we discretize only time here, right? you can take any of the value between this particular given time range, right? We are not considering or measuring any quantity between the particular time duration, as we are not measuring the quantity between the time 0 and time t1. After that, between the t1 and t2 timing, we are not measuring the value. We are measuring the value at the time t1, at t0, at t2. Between the time interval we are not measuring. So the delta t, the time interval between the time slot is same, right, for all the time. So the delta t is ideal for t1 to t0, t2 to t1, up to tn to tn minus 1, right? For an example, the person X is given a task to measure temperature at 11 am daily for the 30 days, right? So we will measure that temperature at sharp 11 am for rest of the 30 days, right? But it is measured between that 11 am at each of the day, the day 1, day 2, day 3, day 4, day 5, and so on. But the temperature that is measured at that particular time or that particular day can be range of between the particular range. So this is how the discrete time signal is working in analog signals, right? After that, let's see a digital signal. In our previous example, we have seen previously that we have discretized the time only. We didn't discretize the magnitude there, right? But in the digital signals, both the magnitude and the time interval both are discretized, right? Signals in which we discretize both the time and the magnitude is called the digital signals. Here at any time duration you can measure that quantity at that particular location, that at the 1 voltage, 2 voltage, 3 voltage, 5 voltage, and so on. You cannot measure the voltage between 1 voltage and 2 voltage and like that, right? So the voltage that we are measuring for a particular operation should take the value only and only equal to that levels, right? For an example, we have seen that 0 voltage, 1 voltage, 3 voltage, 4 voltage, and 5 voltage, and so on. The value should take only equal to that levels only, right? This is how the digital signals are measured, right? Signals can be the digital or analog, right? So analog signals can have the any value between the given range, right? In this figure you can see that this is the analog signal. In that you can take an any value in the given time interval, right? But here in the digital signal you can only get the value at the particular level, right? Here is a 1, a 0 or minus 1, and so on. You can only get the value at a particular level. The digital signals can only have discrete number of the value in the given range, where in the analog signals we can get the any value between the given range for our measurement. Let's see the difference between the analog and digital signals, right? The analog signals are the continuous signals, where discrete analog signals are the continuous signals, where digital signals are discrete signals. You can have any value between that particular time range, that is called the analog signals, and you can only have the value between that particular level at given time range is called the digital signal, right? The devices which are used to work with the analog signals are less flexible. So compared to the digital signals, the devices which are used with the digital signals are more flexible, right? The analog signals are denoted by the sine waves, where the digital signals are denoted by the square waves, right? The analog signal will consume the less bandwidth, where digital signals will consume more bandwidth compared to the analog signals, right? The analog signal has a low cost to the work with, where if you want to work with the digital signals, the cost may be high. You can get, as we have discussed, you can get any value between the given range. So in the analog signals, the continuous range of the values you can get. But where in the digital signal, the discrete values, right, 0, 1, and all kind of signals levels are measured with the help of the digital signals, right? The example of the analog signal is human voice. You can have any peak between the given range, right? But in the digital signals, the computer, DVD, CD, and any other digital devices are storing the digital signals there, right? So this is all about the analog and digital signal. This is the most important topic in the data communication and computer network. The signals have various forms. We can say that periodic and aperiodic, right? So both the signals, analog and digital signals, can be have a two form: the periodic form and a aperiodic form, right? So let's see the periodic form first, right? What do you mean by the term periodic? Periodic signal. A signal is periodic if it completes a pattern within a measurable time frame. You can say that the period and repeats that pattern over the identical subsequent period, right? As you can say that the sinusoidal wave. For an example, a sine wave, it is repeating its pattern with the given time interval, right? The period, the amount of time required to complete one full cycle is called the period. As you can say that in the sinusoidal wave, it is starting from the 0, it will go to the 1, after that it reaches to the 0, after that it is reached to the -1, after that it reaches to the 0. So it is completely, it is time required to completing the whole cycle or whole pattern is called the period. After reaching that the point 0, it will go to the 1, after that 0, -1, 0, and so on. And like that, it is repeating its pattern throughout its journey, right? Period is represented by the T. For an example, analog and digital signals. Here you can see that this wave is repeating its behavior or its pattern in particular time interval. Here you can, in the digital signals, you can see that the signals is repeating its pattern with the particular time interval, right? The periodic signal consists of the continuously repeated pattern within a specific time frame, right? The periodic signal consists of continuous repeated pattern with a specific time frame. So a signal is considered periodic if it is repeat itself after a specific interval of time. A periodic signal is a signal which repeats itself after a specific interval of time. A periodic signal can be represented by the mathematical equation, right? The periodic signals can be represented by the mathematical equation. The value of the periodic signals can be determined at any point of the time interval as it is repeating its behavior or repeating its pattern throughout its journey, right? The periodic signals are deterministic signals. All the bounded periodic signals are power signals, right? Why? All the bounded periodic signals are the power signals because they do not converge a finite value, so that energy is infinite and their power is finite. The signal is energy signal if the energy is finite and power is 0. The sinusoidal waves, cosine waves, triangle waves, square waves are the example of the periodic signals, right? Let's move forward about the aperiodic signals. As you already know, what is periodic signal? So what is a periodic signal according to you? An aperiodic signal changes constantly without exhibiting specific pattern or cycle that can be repeated over the time, right? In the aperiodic signal, there is no pattern which is repeating by its time duration. Note, by using the Fourier transformation, we can transform the aperiodic signals into the infinite number of the periodic signals, right? Any aperiodic signals can be decomposed into the infinite number of the periodic signals, right? And signal is called the aperiodic where it is not repeating itself to a certain interval of time. An aperiodic signal is a signal which does not repeat itself after a specific time interval. And aperiodic signals cannot be represented by any mathematical equation as it is not repeating itself or it is not repeating its cycle with respect of time, right? The value of the aperiodic signals cannot be determined with the certainty at any given point of the time. It may change its behavior, so it is very difficult. We have to measure the aperiodic signals. The aperiodic signals are random signals, right? And aperiodic functions never repeats. Although technically an aperiodic function can be considered like the periodic function with the infinite period, right? As we have seen the techniques of the as we have seen the Fourier transformation, that kind of techniques we will apply and we can convert the aperiodic function into the infinite number of the periodic functions, right? Example of the aperiodic signal is a signal when we are capturing any voice through the microphone or telephone. Also a signal that propagates by the AM radio station or FM radio station are the aperiodic signals, right? Let's see the comparison between the periodic and aperiodic signals, right? For the basic comparison, we have made a table. A signal is considered periodic if it repeats itself after a specific interval of time. Then that signal is called the periodic signal. When it is not repeating itself after a specific time, then that signal is called the aperiodic signals, right? The definition of the periodic signal. The periodic signal is a signal which repeats itself after a specific interval of time, where an aperiodic signal is a signal which does not repeat itself after a specific time of interval. Then that signal is called the aperiodic signal. You can represent the periodic signal by the mathematical equations, where you cannot represent the aperiodic signal with the mathematical equations, right? For the representation, the periodic signals can be represented by the mathematical formulation or mathematical equation, where aperiodic signals are not repeating itself, so it cannot be represented by the mathematical equations. The determination of the value of the periodic signals can be determined by any point of the time, as it is repeating itself in certain pattern in infinite time interval, right? So it is easy to determine its value at any given point of the time. But when we are working with the aperiodic signals, we cannot determine the value at particular time at the given point of the time, as aperiodic signal is not repeating itself with the time duration. So the measurement of any given of time interval, it is easy task for the periodic signals, and it is complex for the aperiodic signals, right? Let's see the type of the signals. The periodic signals are the deterministic signals, right? And aperiodic signals are the random signals, right? As the periodic signals are repeating itself or repeating its pattern with and time interval, it is called a deterministic signal. Where the aperiodic signals are random signals, that its pattern is not fixed with the time interval, right? Let's talk about the infinite period. All the bounded periodic functions are power signals, because they do not converge to an infinite value, so that energy is infinite and their power is finite. The signal is an energy signal if the energy is finite and power is zero, where the aperiodic functions can never repeat. Although technically an aperiodic function cannot be considered like a periodic function, an aperiodic function never repeats. Although technically an aperiodic function cannot be considered like a periodic function with an infinite period. Right? Example of the periodic functions are the sinusoidal wave, cosine wave, triangle wave, square wave, and are the example of the periodic function. An aperiodic function, the example of the aperiodic signals are signals created by the microphone or telephone. When one or two words are pronounced, also the signals are propagated by the AM radio station or FM radio station are the aperiodic signals, right? We have seen the basics of the signals. After that, we have seen its two types: analog signals and what is digital signals. After that, we have seen the form of the signals: periodic and aperiodic. This is all about today's lecture. Thank you for the watching.